So let's talk about the sun. On March 28th, so a couple days ago, we had a solar flare that came out of the sun. So if you look at this image here, let's see what we can see. We see our sun. So this is from NASA, and we have a strong solar flare that erupted from the sun, and here it is on March 28th. So here you can see the sun. The sun is a big ball of gas, and through nuclear fusion creates energy. And you can see here we have the flare. But what is interesting, we just don't have energy to go straight out because of the fact that some of this material is charged, and we have also the magnetic field of the sun. Then you have materials coming out and reacting with the magnetic field. So we have all kind of fun activities right here. And you're going to say, how can we get a great image like this? I mentioned in the previous video that when you look at the sun directly, you have all the energy coming to us. But astronomers are using filters to diminish how much energy is coming to us. They're using different wavelengths and the filters so that they can see different parts of the sun. And here you could see the surface here is all playing. You can see how it goes. We have this part here that is a bit darker. Probably we may have some sunspots right here. And here we have an example of the solar flare. And the question is, how is this happening? So let's see. I have a little video for you that shows that. So this video is one of my favorite animation for the sun. So if you look here, we have the core of the sun where the temperature is probably 10 million degrees. And as the energy is going towards the surface, then it's getting less and less hot to the point where on the surface here, so the photosphere, we have basically some gas moving. Now the density is not as high as the density in the core of the sun. So for an example, if you take our Earth, we have here Earth, we have ocean and the Earth's crust. And then on top of it, we have a thin layer of gas, which is our atmosphere. For the sun, it's a little bit the same thing. The most pressure and temperature is in the center. But as we get closer and closer to the outside, just right here on the outside, the density of the gas is not as high. So it's not a gas and it's not a liquid or solid. It's like in between. And you could see, let's do this video again. You could see how this is playing. So it's the same way if you have a soup at home and you put carrots and noodles and a few other things inside, you will notice that when it boils, we have all the pieces moving. So the warmer pieces go up, the colder pieces go down, and this is what we have right here. But it does happen that when we have energy coming in a specific direction, and then they focus all the energy, that you have here a spout of more energy and matter, and then it creates these eruptions, these flares on the surface. So if you think of an analogy, we have our planet. So Earth has an Earth's core made of iron and nickel. We have the mantle here, which is very hot, and we have the Earth's crust. I know it's an analogy, but ever so often in the Earth's crust, there's a break, and then magma can come out of the surface if we have the Earth. Same thing here for the sun. Ever so often, there's a breach, and then what happened? Matter and energy is coming out. The consequence is something like this that we had a couple days ago when you have extra matter here. What is interesting is this matter is coming out of the sun and therefore has in its solar wind a lot of matter. We have ions, we have energy. Now we're lucky because this flare was on the side of the sun, therefore was moving sideways towards the right here. But if it happened right here in the middle, then a flare would bring towards us a lot more energy, magnetic waves, and that could create difficulties for the telecommunication system on our planet. So this is the information we have here. Something else that is interesting. When you look at the sun, it takes about 8 minutes for the light to go from the sun. 8 minutes, yeah, that's right, to go from the sun to reach Earth. So when you look at the sun, the light that you see is about 8 minutes late. However, if you think of the sun here, and let's see if we can start this over. It's going to So let's see. So if you look, we have fusion right in the core. So as the light and the energy wants to come out, there's a lot of matter here. So sometimes the light and the energy will bounce off atoms like hydrogen and helium, and it will bounce off, and it will take a while for the light to go from the core all the way to the surface. So, oops. So there we go. So here I have a link to an article from NASA. And here someone was asking a good question. It takes about 8 minutes for the light to travel from the sun to us, but it can take 1,000 years or sometimes more for the light to come from the core of the star to us. So here is how it goes. We have here the sun, the energy is produced, and it has to go from the center, oops, there you go, the center all the way to the surface. But we do know that we have convection cells right here in the middle of the star. So the consequence for that, let's see if I can go to the next one. Oh, this. We have here this drawing. So here, let's say that this is the sun. We have here the core where fusion and nuclear fusion happens. And then the light says, okay, let's see if I can get out. But as the light wants to get out, it's bouncing off different particles, hydrogen and helium, some other atoms that are there as well, and then they will be bouncing around. Some of this energy and light rays will be absorbed by the atoms and the matter here, and at some point, if they're lucky, the light ray will be able to reach the surface and then come to us. So not all the energy or all the light coming from the sun actually comes to our eyes. So when you look at the sun, that is true that some of the light rays are about 8 minutes. Others can be 10, 20 minutes old, but some of those light rays and the energy coming to us may be more than 100,000 years old. It's very interesting. It's all in the way that light can travel in the sun itself and also inside the star that is our sun. So this is our second video today. If you have any questions or clarification questions about the sun, let's see if we can put this picture for this week. This one here, perfect. So if you have any questions with respect to the sun, how a solar flare is created, you want more, you have another questions coming from watching this video, put them in the comments below. I always love to read your comments. I consider your questions as part of what I use for this channel to show you new ideas, because keep in mind that when you have a question and you have an answer, it gives you a chance to have another question, have a better question, to have a better understanding on how our world works. On this, I'll see you in the next video, and I will put here a video on probably a probe. There's a probe that is studying the sun, and I'm going to put a link to the video here. You'll see it's interesting. I'll see you there.